Hello and welcome to the second lecture on position and orientation of an object. So at the end of this session, you will be able to explain how to represent the object in 3D space. And second is compute the position and orientation of an object in 3D space. Now let us look at how we represent the object in 3D space. Let us say we have an object and I mark a point Q on the object. I define a universal coordinate system with ZU, that is Z vector, Y vector, and X vector here. Also, when I want to represent the position of the body, I need to know the distance of point Q with respect to your origin over here. Now, to do that, I will find out the position of point Q with respect to X, that is QX over here. Position of point Q with respect to Y, that is QY over here. Position of point Q with respect to Z, that is Z here, QZ. So now if you look at the position of a point can be represented by an array or a matrix, that is 3 by 1 matrix. We can find the position, or we can use this knowledge to do a programming by using a Python code. If you type q equal to 321 in any Python editor, we can print and get the vector. Alternatively, we can also get this vector in terms of importing a numpy dictionary as np. So I can define q as np dot array. Now what is np? Np is an instance of a numpy, and defining an array we can set 3 to 1, that is 3 as x, 2 as a y coordinate, and z as 1, and we can use later on q as an array for doing any programming, and we can print that q in the program. Now once we define the position, now let us know how to define the orientation. So first of all, let us understand what is the difference between position and orientation. For example, if I want to approach, let us say I have a mobile here. If I want to approach from this point to this point, okay, so this is nothing but a position. Now what is orientation? Now suppose I have a gripper like this, and the mobile is kept like this. Okay, now if I go and try to pick it here, then my gripper is not exactly in line with this, so it may not pick it properly. There can be in proper orientation. But if I orient my gripper like this and then hold it, so that way I can have a complete control on the orientation. So that way I have to define the orientation of the object also. For that, I will define I will define the coordinate system for local coordinate system, or we call it as a body coordinate system. When we define a body coordinate system, I define the x like this, I define the z, I define the y. Now, when I want to find out the position, I can directly take the position like this. Okay. But when I want to define the orientation is related to how the x, y, z axis of the body coordinate system are related to your universal coordinate system. So it is generally defined by a rotation matrix. That is why it is defined as R, but we can represent it in any symbol. So this R of B with respect to U, R of B with respect to U, that is orientation of the body coordinate system with respect to universal coordinate system, is represented by X, Y, and Z matrix. And this will be a 3 by 3 matrix. I will explain by using a two link manipulator here. Let us say we have defined our universal coordinate system over here. This blue axis is shown by z axis, y, I just represented like this: z, this one is y, and this one is x, and I represent this as z, yu, and xu. Similarly, this point B, I assume it over here, and this one will be your yb, this one will be your xb, and this one is your zb. And as I said, we have to represent the orientation of B with respect to U. So this matrix represents the position of the local coordinate system with respect to universal coordinate system. So I explain to you one by one. Let us say how I know that a particular axis, let us say xb with respect to xu. This is the xb over here and xu over here. If you look at these two axes, they are collinear. What is the angle between these two axes now? The angle between these two axes is 0. So the component of this B on U will be this component into cosine of 0. Since this is a unit vector, this is also unit vector. So 1 1 cosine 0 becomes 1 1. Next, YB over XU. YB here can be represented like this by green arrow. XU represented like this. What is the angle between XU and XB? 90 degrees. So cosine of the 90 will become 0. Similarly, ZB over here and XU over here, the angle between this ZB and XU is 90 degree. So the cosine of the angle becomes x, that is this vector into this vector, cosine of the 90 becomes 0. So we got one row, that is 1 0 0. Similarly, you can find out the second row. I explain now YB over YU. So if you look at here, YB in green and YU in green over here, they are parallel to each other. So the angle between them is again 0. So that is why we get this as 1. Similarly, XB and YU and ZB and YU, they are having angle 90 degrees with each other. So that is why we'll get cosine of the 90 as 0. Similarly, our ZB over ZU, that is ZB in upper direction, ZU also in upper direction, both are parallel to each other. So the angle between them is 0. That is why we get this vector as 1 and other two as 0. Now this is a Python code just to find out the orientation. So just follow this program. You can type it in the Python editor and we can get the orientation. So I will explain to you how it runs. So we import a numpy as np. I set the angle A1 and A2 as 90 and 0 and 90 degrees. So what this 0 represents? This is the angle made by x-axis with respect to the base x-axis, and A2 is the angle made by x and y axis with respect to corresponding base axis. So this is the same condition I tried to relate over here, that this angle of xu and yu is 0 and the other two axes with respect to xu is 90 degrees. I convert this A1 into radians by importing the mathematical function np in terms of pi. So pi is the inbuilt constant which we can multiply, we can get it through np and just divide it by 180 to convert degrees into radians, a1 radians, a2 radians, and we can find out the orientation matrix. As I said again, this is 3 by 3 matrix. So this is one row, second row, and third row. So how many rows? 3 rows. So same thing over here. So this is our one row, this is our second row, this is our third row. Okay, this is our all second row, and this is our third row. So in that we can see that this A1 is 0, here we'll get 1. Similarly, here we'll get 1, and here we'll get 1. So I just tried to relate the previous matrix as it is, and here as we put 90 degrees, as you can see over here, this becomes 0. Okay, this becomes 0, and this is 0, 0, 0, 0, 1. So just this program is very simple, and this may not have a much value when we do a programming later on, but it will give you idea about how to understand the orientation of the object. These are the two references. So this is all about position and orientation. We will understand the following lectures. So thank you.